Hi everyone! In this video, we are going to be talking about some properties of limits. So just before we get started, in all honesty, these properties I almost never used in AP Calc. I don't think they come up that often, but I wanted to do a video on them just to, just so you guys can be familiar with them. And they are pretty straightforward. So I wouldn't be too concerned, too worried about them. They are, somewhat self-explanatory, and you probably won't see them that much, but we'll go over them anyway. So the first property that we have here is the sum rule. And so this just says that if you're asked to find the limit of a function where the function is the sum of two separate functions, you can easily calculate that by just splitting up the limits. So you can just find the limit of the first function and then find the limit of the second function, and then just add those two numbers together, and that would be your final answer. So we have an example here that will do. So it says, let f of x equal x squared and g of x equal x. Calculate the limit as x approaches 2 of f of x plus g of x. So the sum rule is telling us that we can just calculate these limits separately and then add our final answers together. So let's do that. So we're going to start by calculating the limit as x approaches 2 of f of x. And so remember, f of x is x squared. So the limit as x approaches 2 of x squared is going to be 4. If you don't believe me, you can graph x squared on your graphing calculator or Desmos or something, trace the curve as x approaches 2 from the left and right, and you should get a y value of 4. And then we'll do the same thing for g of x. So the limit as x approaches 2 of g of x is going to equal 2. And again, do that same graphing if you don't believe me, but the limit for that is going to be 2. So now the sum rule says to get our final answer, all we have to do is add these limits together. So the limit as x approaches 2 of f of x plus g of x is just going to equal 4 plus 2, which is equal to 6. So 6 is our final answer for this limit. The next property is the difference rule. So this says that if you're asked to calculate the limit of two functions being subtracted from each other, you can apply the same reasoning, just calculate each limit separately, get those answers, and then subtract them. So we have this example here. Let f of x equal 2x and g of x equal x cubed. Calculate the limit as x approaches 1 of f of x minus g of x. Okay, so let's start by just calculating the limit as x approaches 1 of f of x. And f of x is 2x. So the limit as x approaches 1 is going to be 2. Now we're also going to calculate the limit as x approaches 1 of g of x. And g of x is x cubed. So the limit as x approaches 1 is going to be 1. So now our final answer, the limit as x approaches 1 of f of x minus g of x, is just going to be 2 minus 1, which is equal to 1. So that is our final answer. The next rule is the constant multiple rule. So it says that if you're asked to calculate the limit of a function that's being multiplied by some number, by just some constant number, you can calculate just the limit of that function first, and then once you get that answer, then you can just multiply by whatever that constant was. So in our example, we have let f of x equal square root of x, calculate the limit as x approaches 16 of 3 times f of x. So our rule says that first we can just calculate the limit as x approaches 16 of f of x. Okay, f of x is a square root of x. So as x approaches 16, sorry if I said 17 before, as x approaches 16, the limit should be equal to 4. And now all we need to do is multiply that by 3. So the limit as x approaches 16 of 3 times f of x is just equal to 3 times 4, which is equal to 12. Okay, next rule, the product rule. This says that if we're asked to calculate the limit of two functions that are being, whoops, I didn't want to do that, two functions that are being multiplied by each other, we can just calculate each limit separately and then multiply the final answers. Okay, so in our example, f of x is equal to x and g of x equals 4x. Calculate the limit as x approaches -2 of f of x times g of x. So like all the others, we're going to start by just calculating the limit as x approaches -2 of f of x. And that is going to be equal to -2. Next, we'll calculate the limit as x approaches -2 of g of x. And that is going to be equal to -8. So now to get the limit as x approaches -2 of f of x times g of x, we just multiply the two answers we got, and -2 times -8 is equal to a positive 16. So that's our final answer. Last rule, the quotient rule. So if you're asked to calculate the limit of two functions that are being divided by each other, you can just split that up into the limit of f of x, the limit of g of x, and divide those two final answers. So in our example, f of x is equal to x squared, g of x is equal to x cubed. Calculate the limit as x approaches 2 of f of x divided by g of x. So like all the others, we'll just start by calculating the limit as x approaches 2 of f of x. And that is going to be equal to 4. And then the limit as x approaches 2 of g of x is going to be equal to 8. So to get our final answer, the limit as x approaches 2 of f of x divided by g of x, we just need to take the limit we got for f of x, which was 4, and then divide it by the limit we got for g of x, which is 8. And that simplifies to 1/2. So that would be your final answer. So just so you know, there are some other properties for limits, but it's really unlikely that you'll need them in AP Calc, which is why I'm not going to cover them in this video. So I hope that made sense. And again, don't stress too much about these. They're really not one of the most important pieces of the AP curriculum, but they're good to have in your back pocket in case they ever come up. So hopefully that made sense. And again, if you have any questions, leave them in the comments and be sure to subscribe. Thanks.